Good morning all. The aim of this lecture is to explain the questions asked for CSIR NET examination conducted on February 2022 in the discipline Physical Sciences. So consider this question. In an experiment to measure the charge to mass ratio E by m of the electron by Thomson's method, the values of the deflecting electric field and the accelerating potential are 6 into 10 to the power 6 Newton per Coulomb and 150 volt respectively. The magnitude of the magnetic field that leads to zero deflection of the electron beam is closest to. This is the question. The idea to solve this question is, for a charged particle, the electric field will produce a deflection by the force QE and magnetic field will produce a deflection by the force QV cross B. Okay, for a charged particle in an electric field, it will experience a force QE, where Q is the charge, E is the electric field, and if it is moving in a magnetic field, it will experience a force QV cross B, where V is the velocity of the particle. If we apply simultaneously both these fields, then the combined forces will cause a deflection. If the force due to electric field and force due to magnetic field are exactly equal and opposite, then the deflection will be zero. That is the idea. Here, this electron beam is accelerated by a voltage 150 volt. That means its velocity we can calculate using this equation. The kinetic energy acquired by an electron when it is accelerated through a potential of V volt is given by half mv square equal to EV, where E is the charge of the electron. Solving this, we can calculate V, velocity of the electron beam, and it is given by square root of 2E into capital V, this is accelerating potential, divided by mass of electron. Okay. Force due to electric field is given by F suffix E is equal to EE, and in this figure, the positive plate is in the above the electron beam and negative plate is below the electron beam. So electric field will be acting in the downward direction. Since the electron is negatively charged, the force will be acting in the upward direction. That will produce a deflection in the upward direction, say by an amount of Y. Magnetic field will produce a force which is given by EVB if we are applying the magnetic field perpendicular to the plane of the beam. Suppose I am applying magnetic field into the plane of the paper or into the plane of the board, then V cross B, V is in the direction of, say, if you are considering an axis like this, velocity is along the x direction, magnetic field is along the y direction, then V cross B will be x cap cross y cap, that is in the z cap direction. Z cap direction is actually upward, but the force acting on the electron, since the charge of electron is negative, that will be opposite, that is in the minus z direction, okay, in the downward direction. The magnetic field will deflect the electron beam in the downward direction. If these two forces are equal, EE equal to EVB, then the deflection will be zero, because electric field will produce a deflection in the upward direction, magnetic field will produce a deflection in the downward direction. If these two forces are equal, the deflection will be zero. Okay. Cancelling this E, you will get magnetic field B equal to electric field capital E divided by velocity. We already have an equation for velocity, root 2 EV by m. Substituting that, B is equal to electric field into square root of m divided by 2 EV, where m is the mass of electron, 9.1 into 10 to the power minus 31. E is the charge of the electron, 1.6 into 10 to the power minus 19. Electric field and potentials are given. Substituting these values, you will get B approximately equal to 0.8. So in the given options, the last option is correct. Okay, I hope the idea is clear. Over to the next question. The volume integral I is equal to triple integral A dot del cross A d cube x is over a region V bounded by a surface sigma. An infinitesimal area being n cap ds, where n cap is the outward unit normal. Okay, if it changes to I plus delta I when the vector A is changed to A plus del lambda, then delta I can be expressed as, when you change this vector field A by adding the gradient of a scalar, what is the change in this integral? Delta I, that is the question. Okay, one integral is given. In that, the vector field A changes as per this equation. What will be the change produced in the integral? That is the question. Okay. So this is the given integral. I is equal to triple integral A dot del cross A d cube x. When you change A to A plus del lambda, this I becomes I plus delta I. I can write this I plus delta I is equal to triple integral V. A you have to change to A plus del lambda dot del cross, again A you have to write A plus del lambda d cube x. A plus del lambda dot del cross A, you have to open this curly bracket, del cross A plus del cross del lambda d cube x. We have a familiar identity. Curl of gradient is always 0. Curl of gradient is always 0. So this quantity del cross del lambda becomes 0. Remaining is triple integral A plus del lambda dot del cross A d cube x. We can split this integral into 2 because integration operation is linear. You can write A dot del cross A d cube x plus del lambda dot del cross A d cube x. Split this integral into 2. This first term is the given integral I, so you can substitute it as I. I plus delta I equal to I plus, the last term is triple integral V del lambda dot del cross A d cube x. This I and this I will cancel. Delta I is equal to volume integral del lambda dot del cross A d cube x. Again, another identity, del dot A cross B, divergence of cross product of two vectors, del dot A cross B is B dot del cross A minus A dot del cross B. If we identify A as del lambda, then this identity becomes del dot del lambda cross A. Instead of B, I will write A. Instead of A, I will write del lambda. Del dot del lambda cross A is equal to A dot del cross del lambda minus del lambda dot del cross A. Again, curl of gradient is always 0. So this term will vanish. Del cross del lambda will vanish. Therefore, I can write this term, negative term, you have to take it to the left hand side and this you take it to the right hand side. Therefore, del lambda dot del cross A is minus of del dot del lambda cross A. You can substitute for this quantity as minus del dot del lambda cross A. By using Gauss divergence theorem, volume integral del dot A d cube x is closed surface integral A dot n cap ds. Okay, this Gauss divergence theorem will convert a volume integral to a closed surface integral. So applying that theorem here, this negative sign is the triple integral, volume integral becomes closed surface integral, and del dot this vector field becomes vector field dot n cap ds. So delta I equal to minus closed surface integral del lambda cross A dot n cap ds. Correct answer is option C. Option C. Okay. Cp by Cv of the specific heats at constant pressure and volume of a monoatomic ideal gas in 2 dimensions is. Okay, the important point is it is monoatomic, and the second one, it is in 2 dimension, not in 3 dimension. Okay, for monoatomic ideal gas in 2 dimension, the only possible motion is translation in a plane. Since it is monoatomic, there is no possibility of vibration. If it is a diatomic molecule, we can consider the bond as a spring and there can be a vibrational motion. Also, there can be rotation about an axis passing through the center. But for a monoatomic molecule, there is no such possibilities. For a single atom, there cannot be any vibration, there cannot be any rotation. The only possibility is translation. And since this in a 2 dimension, the motion should be in a plane. Okay, so the total number of degrees of freedom is 2. Translation along x, translation along y. Each degrees of freedom contributes half k towards Cv as per equipartition theorem. Each degrees of freedom contributes half k towards Cv. Therefore, Cv of one atom, since it has 2 degrees of freedom, it is 2 into half k, that will be k. If you are considering 1 mole, the molar specific heat at a constant volume Cv is k into 1 mole contains Avogadro number of molecules, k into Na. K into Na is nothing but ideal gas constant R. And from Mayer's relation, we have Cp minus Cv is equal to R. Therefore, Cp equal to Cv plus R. It is R plus R, 2R. Therefore, Cp by Cv is 2R by R. It is 2. Okay, it is 2. The correct option is option B. If it is a monoatomic gas in 3 dimension, answer will be 5 by 3. Answer will be 5 by 3. Because here the degrees of freedom becomes 3 and 3 by 2 k, 3 by 2 R and 5 by 2 R. The ratio will be 5 by 3. But for a monoatomic gas in 2 dimension, Cp by Cv is 2. Okay. Next question. The volume of the region common to the interiors of 2 infinitely long cylinders defined by x square plus y square equal to 25 and x square plus 4z square equal to 25 is best approximated by. So, volume of a region, we can find that by integrating an infinitesimal volume dV, integrating over the allowed region, you can calculate the total volume. In Cartesian coordinates, this dV, you can write it as dx dy dz. Okay, so triple integral dx dy dz. Okay, what are the limits or what is the region? Region is bounded by the limits of x, y, z. You have to find the limits of x, y, z. Given x square plus y square equal to 25. That is, y is plus or minus square root 25 minus x square. So, in the allowed region, y will vary from minus root 25 minus x square to plus root 25 minus x square. Again, x square plus 4z square equal to 25 means z equal to plus or minus 1 by 2 into square root of 25 minus x square. So, the allowed region will extend from minus half root 25 minus x square to plus half root 25 minus x square. Okay. Now, what is the limit of x? X value will vary from minus 5 to plus 5 because this x square plus y square equal to 25 represents a cylinder whose base is a circle of radius 5 in the xy plane and it extends along the z axis up to infinity. That is x square plus y square equal to 25. X square plus 4z square equal to 25 is actually a cylinder whose axis is y and whose base is in the xz plane. Again, At z equal to 0, its x value is plus 5 and minus 5. Okay, so the limits of x should be minus 5 to plus 5. So I will get v equal to integral minus 5 to 5 dx, integral minus root 25 minus x square to root 25 minus x square dy, integral minus half root 25 minus x square to half root 25 minus x square dz. Integral dz is z, put the limits. Integral dy is y, put the limits. Since this contains x, we have to wait for the integration in x. Substituting these limits, you will get 2 into square root 25 minus x square. Substituting these limits, you will get root 25 minus x square into dx. Root 25 minus x square into root 25 minus x square becomes 25 minus x square. 2 you can take outside. Integral minus 5 to 5 25 dx minus integral minus 5 to 5 x square dx. Integral dx is x, putting the limits, you will get this. Integral x square dx is x cube by 3, putting the limits, you will get this term. V is equal to 2 into, this is 25 into 10, 250 minus 250 by 3. Solving, the final answer is 333.3. 333.3. So the correct option is option B. Option B. I hope it is clear. Now coming to the next question. A particle thrown with a speed v from the Earth's surface attains a maximum height h, and h is measured from the surface of Earth. Okay. If v is half the escape velocity and r denotes the radius of Earth, then h by r is. Okay. The idea behind this question is conservation of energy. You know that when this particle is thrown from the surface of Earth, it will have some kinetic energy. When it attains the maximum height, its kinetic energy becomes 0. So there is a change in kinetic energy, and that will be converted as potential energy, because gravity is a conservative force. Total mechanical energy should be conserved. That is the basic idea. The kinetic energy on the surface of Earth is half mv square. Potential energy, by mistake there is a chance to take the potential energy on the surface as 0, and at a height h you will take it as mgh. But that is not valid here, because this height is comparable to radius of the Earth, because all the options are 2 by 3, 1 by 3, 1 by 4, 1 by 2, etc. So h is comparable to the radius of Earth, and in that height mgh is not a valid equation. Mgh is applicable only for heights which is very small compared to radius of Earth. Here you have to use the standard expression minus gmm by r for the potential energy. Minus gmm by capital R on the surface of Earth, and at a height h it becomes minus gmm by r plus h. So these are the potential energies on the surface of Earth and at the maximum height. So we got potential energy and kinetic energy at both these points. You can equate the sum of these energies. So on the surface of Earth, or you can equate the change in kinetic energy and change in potential energy. What is change in kinetic energy? It is half mv square. That should be equal to change in potential energy. Gmm divided by r minus gmm divided by r plus h. Okay. But the initial velocity is given as escape velocity by 2, half of escape velocity. Escape velocity is given by square root 2gm by r, where r is the radius of the Earth, g is gravitational constant, m is mass of Earth. So you can substitute for this v square as ve square divided by 4, and it becomes 2gm by 4r. So the left hand side becomes half m into 2gm by 4r. Right hand side is gmm by r minus gmm by r plus h. You can take the LCM, and it becomes h into gmm divided by r into r plus h. Gmm will cancel both sides. This 2 will cancel. Left hand side becomes 1 by 4r. Right hand side becomes h divided by r plus h into r. Okay. R will cancel. Finally, r plus h by h equal to 4. R by h plus 1 equal to 4, or h by r becomes 1 by 3. H by r becomes 1 by 3. The correct option is option B. I hope it is clear. Over to the next question. A monochromatic source emitting radiation with a certain frequency moves with a velocity v away from a stationary observer A. It is moving towards another observer B, which is also at a rest, along a line joining the two. The frequencies of the radiation recorded by A and B are VA and VB respectively. If the ratio VA by VB is equal to 7, then value of V by C is. Okay. The idea is definitely Doppler effect. You have two observers, both are stationary, A and B. A source is moving away from A and it is moving towards B, because that is moving along the line joining A and B. Okay, so S is moving away from A and is moving towards B. If a source is moving away from a stationary observer, according to Doppler effect of light, you have frequency measured by A is equal to actual frequency into square root of 1 minus V by C by 1 plus V by C. Okay, in the numerator you have a minus because the frequency observed by A will be less compared to the actual frequency. But for the observer B, source is moving towards observer. Therefore, the frequency will increase. And the equation is nu B equal to frequency measured by B is equal to actual frequency nu 0 into square root of 1 plus V by C by 1 minus V by C. Because this will increase. Numerator is 1 plus V by C, denominator is 1 minus V by C. Okay, this quantity is greater than 1. If we take the ratio nu B by nu A, it will be 1 plus V by C divided by 1 minus V by C, because nu 0 will cancel and square root 1 plus V by C into square root 1 plus V by C becomes 1 plus V by C divided by 1 minus V by C. It is equal to 7. It is given in the question. Nu B divided by nu A is 7. Therefore, 1 plus V by C equal to 7 minus 7 V by C. Rearranging, 8 V by C equal to 6. V by C equal to 3 by 4. The correct option is option C. Option C. Consider next question. A particle in one dimension executes oscillatory motion in a potential V of x equal to A mod x, where A is greater than 0, is a constant of appropriate dimension. If the time period t of its oscillation depends on the total energy E as e raised to alpha, then the value of alpha is. Okay. It is given that potential is a modulus function, A mod x. You can plot that potential. In the x-axis, you have the variable. In the y-axis, you have potential. And mod function, it is something like this. Okay, it is linear. But for positive as well as negative x, the mod x is positive. Graph will be in the shape of English alphabet V. So this is the graph of potential. Okay. What is total energy? Total energy of the particle E is kinetic energy plus potential energy. Kinetic energy is in one dimension, you have only one variable x, then velocity is x dot and kinetic energy is half m x dot square plus potential energy is A mod x. At extreme points, if this is the extreme point, if it can go up to this, if this is the extreme point x naught, then at extreme points the velocity becomes 0, x dot becomes 0, and if you put x dot equal to 0, E equal to A mod x naught. If x naught is the extreme point, we can write E is A mod x naught. If you substitute here, you will get A mod x naught. You can take this to the left hand side, minus A mod x equal to half m x dot square, and x dot is square root of 2 by m into a into mod x naught minus mod x. Okay. Now you consider a plot of x dot versus x. We can see that when x equal to 0, in this expression, when x equal to 0, x dot is root 2e by m, When x equal to e by a, then x dot is equal to 0. Okay. So this is the behavior. It is not a straight line because this equation is quadratic, and this is the plot of function. I will show you the function. It is square root of 2 minus x. Okay. In our case also it is something like square root of some constant minus the variable. So the graph will be something like this, and this is only the first quadrant. Actually, when the particle executes oscillation about this potential, its velocity versus position graph will be something like this. This is in the first quadrant, then it will go to this side, then it will go to this side, then it will go to this side. This is not an ellipse. You will get an ellipse for the case of harmonic oscillator. If this potential is half m omega square x square, you will get an ellipse. But in this case, this is not an ellipse. This shape is something like this. And time period is actually the total time taken for this travel. And from the symmetry of this figure, I can take only the first quadrant and the time as t by 4. Okay. I can take the first quadrant to find the 1 by 4th of time period. That is my idea. In the first quadrant, this x is positive. Therefore, mod x you can replace it with x, and mod x naught you can replace it with x naught in the first quadrant, because mod x is positive. What is the definition of mod x? Mod x is equal to x for x greater than 0 and minus x for x less than 0. And now I am considering the region for x greater than 0. So you can substitute mod x as x, mod x naught as x naught. Therefore, x dot is equal to square root of 2 by m a into x naught minus x. Okay. X dot is dx by dt. It is square root of 2 by m a into x naught minus x. You can take dt to the right hand side and this entire quantity to the left hand side and integrating both sides. Integral 0 to t by 4 dt is equal to integral 0 to x naught dx by square root of 2 by m a into x naught minus x. Why it is 0 to t by 4? I am taking only 0 to x naught in the first quadrant. Okay, 0 to x naught in the first quadrant means this is x naught. Okay, this is the maximum value x naught. 0 to x naught in the first quadrant means you will get 1 by 4th of period. Okay, so the time will vary from 0 to t by 4 when you increase the amplitude from 0 to x naught. Okay, so this is the integral to solve. Put x by x naught is equal to u. In order to make the variable a dimensionless quantity, put x by x naught equal to u. That is, whenever you have dx, you can write it as x naught du. Therefore, that integral becomes integral 0 to 1 x naught du divided by square root of 2 by m a x naught into 1 minus x by x naught. But 1 minus x by x naught is 1 minus u. You can take these quantities. These are all constants. You can take this outside. X naught also you can take outside, it is amplitude. Integral 0 to 1 du by square root of 1 minus u. This quantity will give you just a numerical value. Integral 0 to 1, u is a dimensionless quantity. Integral 0 to 1 du by root 1 minus u will just give you a numerical value. This is also a numerical value. So the left hand side is actually t by 4. Okay. So 1/4 the period is proportional to here you have an x naught in the numerator, a root x naught in the denominator. So that will give you root x naught in the numerator. So t by 4 is proportional to root x naught. All other quantities are constants. Therefore, t is proportional to x naught raised to half. But you already know that E is AX naught in the first quadrant. So T proportional to x naught raised to half means T proportional to E raised to half. T proportional to E raised to half. Therefore, the value of alpha is half. The question is to find alpha such that T is proportional to E raised to alpha. The correct answer is option 2. Option 2. I hope it is clear. You have to plot a potential. Then you can plot this x dot versus x diagram, and you can interpret the total period as 4 times the period of 4 times the time taken to travel from 0 to x naught. That is the idea. Okay, and you can write, no need to do this integral because it is not easy to solve this integral. But in order to find the dependence of x naught, you can simply make this integration over a variable which is dimensionless. Okay, that is the idea here. Then you will get T proportional to x naught raised to half or T proportional to E raised to half. Okay. The next question is, a conducting wire in the shape of a circle lies on the xy plane with its center at the origin. A bar magnet moves with a constant velocity towards the wire along the z-axis. So this is origin, this is z-axis, and this magnet coming from the negative z direction. Okay, here z value is negative, here z value is positive. Direction is positive z direction, but initial coordinates of these magnets are negative. Okay. We take t equal to 0 to be the instant at which the midpoint of the magnet is at the center of the wire loop. When the magnet's midpoint is at the center of the wire loop, the time is taken as 0. Okay. And the induced current to be positive when it is counterclockwise as viewed by the observer facing the loop and the incoming magnet. So for an observer facing the loop and the incoming magnet, if current flows in the anti-clockwise direction like this, he will treat the current as positive. For this observer, if the current goes like clockwise, he will treat that current as negative. That is the direction sense of current. Okay, in this problem, the current direction have to be choose such that if the observer sees the current as anti-clockwise, it is positive. And if it is clockwise, it is negative. What is the best diagram for describing this current? That is the question. Okay. Now, when this magnet approaches the loop, there is a flux change associated with the loop, and according to Faraday's law, an EMF will induced in the loop, and since the loop is closed, a current will flow through it. According to Faraday's law, when the magnet moves into the coil, a current will flow through the coil. According to Lenz's law, that current flow is such that it opposes the cause producing the current. What is the cause producing the current? The inward motion of the magnet. So the induced current will flow in a direction such that it opposes the inward motion of the magnet. In order to oppose the inward motion of the magnet, the nearby pole is north pole. So this loop will behave like a magnet with north pole on this side. When you have a wire loop, if the current flows in the anti-clockwise direction, when you look from this side, okay, if a current flows in this loop in the anti-clockwise direction, when you look from this side, that pole will behave like north. Okay, because if you put arrows at the end of north n, then it will be in the anti-clockwise sense. Okay, that is the easy way in which you can understand the pole of a circular loop. Okay, if in a circular loop the current flows in the anti-clockwise direction, that will behave as north pole, And if the current flows in the clockwise direction, then that will behave as south pole. Okay. When this magnet approaches the loop, the north side approaches the loop, so this loop will try to oppose that motion. So the nearby face of this loop will have to act like north pole. So if you look from this side, the current should flow anti-clockwise. That means when you look from this side, that current will looks like clockwise. For an observer on the side of magnet, this loop, current on this loop will be flowing anti-clockwise direction. But for an observer standing here, that current will looks like clockwise. That means the direction is clockwise, implies the current is negative. Okay. So when the magnet approaches the loop, the current is negative. So the current is negative means you can neglect the first two options. This is wrong, because at t equal to 0, the magnet is at the center for negative time. Okay, the magnet is on the left hand side. At that time, the current is negative. Okay, so you can neglect these two options. When the magnet passes through the loop, then when it moves in the forward direction, again a current will be induced because there is a change in flux. But now the induced current will try to oppose the outward motion of the magnet. So the induced current will try to attract this magnet. Okay. So when the magnet moves outward, the south pole is in this side. The magnet will try to attract that south pole. So this end, the near end of this loop should have north pole. So the current should flow in the anti-clockwise direction when viewed from this side. Okay, so anti-clockwise direction means current is positive. After 0 or for t greater than 0, current is positive. Hence, you can neglect this option also. The correct option is this one. For t less than 0, current is negative. And for t greater than 0, current is positive. Why it is like a sharply picked function? Because for a very large distance from the loop, there is no current. But when this magnet approaches the loop, the current suddenly rises, but in the negative direction. But when the magnet reaches at the center of the loop, the current becomes 0. And then when magnet moving away from the loop, the current becomes positive. Okay, that is why this behavior. Coming to the next question. The volume and temperature of a spherical cavity filled with black body radiation are V and 300 Kelvin respectively. If it expands adiabatically to a volume 2V, its temperature will be closest to. Actually, this is a question of particles that obey Bose-Einstein statistics, and from the derivations of black body radiation, we can show that for a black body radiation cavity, Vt cube is constant. For an ideal gas, this is not the case. For a black body radiation cavity, it is a Bose gas, and for Bose gas, the relation between volume and temperature is Vt cube is constant. Okay. So here we can write V1 T1 cube is V2 T2 cube. V1 is V, T1 is 300, V2 is 2V, T2 is unknown. So T2 is equal to 300 divided by cube root of 2. Cube root of 2 is 1.25. So 300 by 1.25, it is approximately 240 Kelvin. So this is a straightforward question if you know this relation. For an ideal Bose gas, not an ideal gas, for an ideal Bose gas, the relation between volume and temperature is Vt cube is constant. Okay. Next question is, the total number of phonon modes in a solid of volume V is integral 0 to omega d g of omega d omega is equal to 3n, where n is the number of primitive cells. Omega d is the Debye frequency and density of photon modes is g of omega is av omega square, where a is greater than 0. If the density of the solid doubles in a phase transition, Debye temperature theta d will be. Okay. So already this integral is given 0 to omega d g of omega d omega equal to 3n. G of omega is also given a v omega square. Substituting this value here, you will get a v into omega d cube divided by 3 equal to 3n. So omega d cube is 9n by av. Omega d is 9 by a. This n by v you can write it as small n, number density. Okay, so it is 9n divided by a. This n is number density, whole raised to 1 by 3. Okay, but Debye temperature theta d is defined as h cut omega d by t. H cut omega d by t. This is the definition of Debye temperature. So substituting the value of omega d, we will get h cut by t into 9n by a raised to 1 by 3. Therefore, theta d proportional to n raised to 1 by 3. If n doubles, theta d increases by a factor of 2 raised to 1 by 3. If n doubles, theta d increases by a factor of 2 raised to 1 by 3. The correct option is increases by a factor of 2 raised to 1 by 3. Option B. Option B. Okay. Next question is, a satellite of mass m orbits around Earth in an elliptic trajectory of semi-major axis A. At a radial distance r equal to r0, measured from the center of the Earth, the kinetic energy is equal to half the magnitude of the total energy. If m denotes the mass of the Earth and the total energy is minus gmm by 2a, the value of Rho by A is nearest to. Okay. A satellite moves in an elliptic trajectory. Satellite mass is m and Earth mass is capital M. When it is at a distance Rho from Earth, its kinetic energy is equal to half the magnitude of total energy. That is given. Question is to find Rho by A. Okay. What is the total energy of a satellite in an elliptical orbit? It is given by E is equal to minus gmm by 2a, where A is the semi-major axis. Okay, total energy of satellite in an elliptical orbit, it is minus gmm by 2a. This is a result from central force problem. Okay, and since the motion is in the gravitational field, it is a conservative force field. Total mechanical energy is conserved. At this point, the kinetic energy is half mv square. Potential energy is minus gmm by Rho, and that is equal to the value of total energy. Total energy at any point is equal to this value. Here we are considering the total energy at Rho, and you can equate it to minus gmm by 2a. Therefore, half mv square equal to, you can take this to the left and right hand side, gmm into 1 by Rho minus 1 by 2a. But it is given kinetic energy is half of total energy. Half mv square equal to half of gmm by 2a. Substituting here, you will get gmm by 4a equal to gmm into 1 by Rho minus 1 by 2a. So 1 by 4a equal to 1 by Rho minus 1 by 2a. 1 by 2a you can take into the left hand side. So 3 by 4a equal to 1 by Rho. Rho by a equal to 4 by 3. It is 1.33. 1.33. This is the correct option. Okay. Option A. Next question. The energy levels of a non-degenerate quantum system are En equal to n E0, where E0 is a constant and n equal to 1, 2, 3, etc. At a temperature T, the free energy F can be expressed in terms of average energy E by. Okay, This is a question from statistical mechanics. Free energy, we know from the definition of canonical ensemble, F equal to minus kT log Q, where Q is partition function, K is Boltzmann constant, T is temperature. And average energy E is minus dou by dou beta of log Q. Again, beta is 1 by kT, Q is partition function. And the system given is having a large number of energy levels. First one is having energy E0, putting n equal to 1. Then 2 E0, 3 E0, 4 E0, etc. These are the energy levels. Therefore, partition function is sum over all states exponential minus beta E. So, first state is E0, e raised to minus beta E0, plus e raised to minus beta 2 E0, plus e raised to minus beta 3 E0, plus etc. This is partition function. And this is sum to infinity of a geometric progression with the first term e raised to minus beta E0, common ratio again e raised to minus beta E0. Sum to infinity of a GP is S equal to A by 1 minus R. Here A is e raised to minus beta E0, R is again e raised to minus beta E0. You can take this e raised to minus beta E0 on the numerator to denominator. That makes it 1 by e raised to minus beta E0, and that becomes e raised to beta E0. This will becomes 1. This is partition function Q. Then you can find log Q. Log Q is log 1 by e raised to beta E0 minus 1. Log A by B is log A minus log B, but log 1 is 0 minus log B. That makes this minus positive. So it is kT log e raised to beta E0 minus 1. This is free energy. E, average energy is minus dou by dou beta log 1 by e raised to beta E0 minus 1. That is again log A by B is log A minus log B. That makes it dou by dou beta of log e raised to beta E0 minus 1. If you take derivative with respect to beta, you will get 1 by e raised to beta E0 minus 1 into e raised to beta E0 into E0. Okay, because derivative is with respect to beta. From this equation, you can write e raised to beta E0 minus 1 as E0 by E into e raised to beta E0. Substitute this value here. So, F is equal to kT log E0 by E raised to beta E0. Log AB is log A plus log B. So, make this kT log E0 by E plus kT log e raised to beta E0. Log and E will cancel. So, that makes it beta E0. Beta is 1 by kT. kT and kT will cancel. F is equal to E0 plus kT log E0 by E. But in the options, there is no such option. So, make this E0 by E. You can write it as E by E0 by putting a negative sign. So, F is equal to E0 minus kT log E by E0. E0 minus kT log E by E0. Correct option is option C. E0 minus kT log E by E0. I hope it is clear. Next question. Again from statistical mechanics. A polymer made up of n molecules is in thermal equilibrium at temperature T. Each monomer could be of length A or 2A. The first contributes 0 energy while the second one contributes epsilon. Average length in units of Na of the polymer at a temperature T equal to epsilon by Kb is. Kb is Boltzmann constant. So you have to find the average length. And there are total n monomers, some having length A, some having length 2A. Suppose small n are the number of chains having length A with the energy 0. Then capital N minus n will have length 2A and energy epsilon. Total is capital N and there are only two types of monomers. One having length A and energy 0, the other having length 2A and energy epsilon. Okay, I will take the numbers as small n and capital N minus n. Then, what is partition function? Partition function Q is sum over all the energy states. Here, small n numbers have energy 0. So, n into e raised to minus beta 0. plus n minus n have energy epsilon. So n minus n into e raised to minus beta u. That will make partition function as n small n plus capital N minus n into e raised to minus beta epsilon. Okay. What is average value of a quantity? For length, the average length is L bar is equal to sigma I pi Li. Okay. Where pi is the probability of having length Li. Here there are only two possibilities. One is A and the other one is 2A. If n monomers have length A, the total length will be Na. If n minus n monomers have length 2A, the total length will be n minus n into 2A. So L1 is Na and L2, there are two possibilities. L2 is n minus n into 2A. Respective probabilities are P1 and P2. Then average length will be P1 into Na plus P2 into n minus n 2A. Now we have to find the probabilities. Probability is P1 is n into e raised to minus beta E1 by Q, and that is n divided by small n plus capital N minus n. This is partition function. Similarly, P2 is capital N minus n into e raised to minus beta epsilon divided by partition function. Substituting this P1 and P2 here, you will get L bar as a n square by small n plus capital N minus n into e raised to minus beta epsilon plus 2a into n minus n square e raised to minus beta epsilon by n plus n minus n e raised to minus beta epsilon. We have to find the equilibrium value for a temperature T equal to epsilon by K. So substituting for epsilon as Tk, this beta epsilon is actually epsilon by Kt. So epsilon by K is equal to T implies beta epsilon is equal to 1. Okay, so you can substitute for beta epsilon as 1. That will make it L bar is equal to n square plus 2 into n minus n square e raised to minus 1 divided by n plus capital N minus n into e raised to minus 1 into A. Now the answer is the average length in units of Na, So take an n outside. Again from numerator and denominator take another n and cancel. Then the numerator that becomes n square by capital N square plus 2 into 1 minus n by n whole square e raised to minus 1. Denominator it is n by n plus 1 minus n by n into e raised to minus 1. Okay, 1 n cancels, capital N from numerator and denominator cancels, and 1 n is there. Okay, Na. At equilibrium, this small n becomes capital N by 2. This small n becomes capital N by 2 and small n by n becomes half. Why? Because in statistical mechanics, you know that the equilibrium state is the one with the maximum number of microstates. Okay, for a system, the equilibrium state implies the state with the maximum number of microstates. What are the total number of microstates in this case? There are only two possibilities. Monomers with the length A and monomers with the length 2A. Small n is the number of monomers with the length A. Capital N minus n is the number of monomers with the length 2A. The total possibilities for arranging this is given by capital N factorial divided by small n factorial into n minus n factorial. This is a standard result in statistical mechanics. Now in order to maximize omega, it is easy to maximize log omega. Okay, log omega. Because if you are taking log omega, you will get an idea to avoid this factorial. Log omega is log n factorial by small n factorial into n minus n factorial. Log a by b is log a minus log b. So substituting or applying that result, you will get log n factorial minus log small n factorial minus log n minus n factorial. If n is very large, you can apply Stirling's formula, and n factorial is n log n minus n. Applying that formula for the first term, you will get n log n minus capital N. For this term, you will get small n log n minus small n. For this term, you will get n minus n log n minus n minus n minus n. That last terms will cancel. Okay, that last terms will cancel. Finally, you will get n log n minus small n log n minus capital N minus n into log n minus n. At equilibrium, log omega is maximum, so first derivative with respect to small n will vanish. You can take this first derivative with respect to small n. This is constant. Here minus n into log n derivative is 1 by n. Then minus log n into n derivative 1. Minus n minus n into log n minus n derivative is 1 by n minus n into minus 1. Minus log n minus n into n minus n derivative is minus 1 is equal to 0. Rearranging, you will get log n minus n by n equal to 0. Log n by n minus 1 equal to 0. That is n by n minus 1 is 1. And n by n is equal to 2. Small n equal to n by 2. So at equilibrium, this is a standard result. At equilibrium, if you have a two-level system, they will occupy the equal probability. Okay, so the number of monomers with length A and number of monomers with length 2A will be equal. That is small n by n equal to 1 by 2. So 1 minus small n by n is also 1 by 2. Substituting that values in the equation for L bar, you will get 1 by 2 plus e raised to minus 1 divided by 1 by 2 plus 1 by 2 e raised to minus 1 into Na, and that is e plus 2 by 2e divided by e plus 1 by 2e into Na, and that is e plus 2 by e plus 1 into Na. Okay, the correct option is option D. Okay. The next question is from mathematical methods, numerical methods. The Newton-Raphson method is to be used to determine the reciprocal of the number x equal to 4. If we start with initial guess 0.20, then after the first iteration, reciprocal is. Here, the question is very simple. But for applying Newton-Raphson method, you have to identify the function. Usually in Newton-Raphson method, you will given f of x is equal to 0 and x naught some value a. You have to find the value of x. Okay, but here it is given that you have to find the reciprocal of x equal to 4. So the first thing you have to do is to make an equation. Let the reciprocal of x equal to 4 be y. Then I can write y is equal to 1 by 4. Y equal to 1 by 4. So 4y equal to 1 and 4y minus 1 equal to 0. Now I have an equation. Call this as f of y. And the given initial guess is 0.20. You can take it as y naught. And according to Newton-Raphson method, if f of y equal to 0 with a given initial guess y of 0 equal to y naught, the next iteration value is y1 equal to y naught minus f of y naught by f prime y naught. Here already you obtained f of y. So f of y naught is put y as 0.2, 4 into 0.2, 0.8 minus 1, it is minus 0.2. Derivative is f prime y is 4. When you put y equal to 0.2, there is no y, so f prime y naught is again 4. In this equation, y1 equal to y naught is 0.2, f of y naught is minus 0.2, there is already a negative sign here, that makes it plus, divided by 4. 0.2 divided by 4 is 0.05, so it is 0.25. After the first iteration, you will get 0.25. Option C is the correct answer. And the interesting point is, after the first iteration itself, you will get the correct answer. Reciprocal of 4 is actually 0.25. This is the idea. Over to the next question. The Legendre polynomials Pn of x, n is equal to 0, 1, 2, satisfying the orthogonality relation minus 1 to 1 Pnx, Pmx dx equal to 2 by 2n plus 1 delta nm on the interval minus 1 to 1 may be defined by the Rodrigues formula Pn of x equal to 1 by 2 raised to n n factorial d raised to n by dx raised to n x square minus 1 raised to n. The value of the definite integral minus 1 to 1 4 plus 2x minus 3x square plus 4x cube p3x dx is. This is the question. Given the orthogonality relation, our aim should be to convert this things in the bracket, this polynomial, in terms of Legendre polynomials, then you can apply this orthogonality relation, because this integral is -1 to 1. If you can convert this entire thing in the open bracket in terms of Legendre polynomials, you can definitely apply this this orthogonality relation. So that is the aim. Okay, so express 4 plus 2x minus 3x square plus 4x cube using Legendre polynomials. Let it be a0 p0x plus a1 p1x plus a2 p2x plus a3 p3x. Why I stopped up to a3 p3x? Because the leading term here is x cube, and in p3 you will have x cube. In p4 you will have x raised to 4. There is no x raised to 4 here. So definitely this polynomial will be a combination of 4 Legendre polynomials p3, p1, p2, p0, p1, p2, p3. We have to find a0, a1, a2, a3. For that we have to find values of p0, p1, p2 and p3. No need to by heart those quantities for an exam. Here it is given the Rodrigues formula. From the Rodrigues formula you can calculate these values p0, p1, p2 and p3. What is pnx? 1 by 2 raised to n factorial d raised to n by dx raised to n x square minus 1 raised to n. If you put n equal to 0, this 1 by 2 raised to 0 is 1, n 0 factorial is 1. D raised to 0 means no need to take derivative. X square minus 1 raised to 0 is 1. So the final answer is 1. P1, put n equal to 1. So this will be 1 by 2 d by dx of x square minus 1. It is 2x by 2, it is x. P2x, put n equal to 2. 1 by 4 into 2 factorial d square by dx square of x square minus 1 whole square. If you take one derivative, you will get 2 into x square minus 1 into 2x. This 2 and this 2 will come outside, and this makes it 1 by 2 d by dx of x cube minus x, and it is 1 by 2 into 3x square minus 1. This is P2 of x. P3 of x is 1 by 8 into 3 factorial into d cube by dx cube x square minus 1 whole cube. It is 1 by 48 into, take one derivative, then this becomes d square by dx square into 3 into x square minus 1 whole square into 2x. 3 into 2, 6, you can take outside, that makes it 1 by 8 d by dx of 5x raised to 4 minus 6x square plus 1. Okay, one more derivative I did. Then the last derivative, I will get 1 by 2 into 5x cube minus 3x. This is the value of P3x. Once we obtain all these values, substitute back in the first equation. So a0 into p0x plus a1 into p1x plus a2 into p2x plus a3 into p3x. No need to calculate all these coefficients. You just calculate a3. For calculating a3, you can equate the coefficient of x cube on both sides. 4 equal to 5 by 2 a3. So a3 is 8 by 5. In the orthogonality relation, right hand side is non-zero only when m equal to n. In your question, the outside Legendre function is p3x. So from this inside bracket, if there is a p3x, that will contribute a non-zero answer. All other things will contribute 0. So you have to worry only about the p3 term here. And the coefficient of p3 term is a3, and no need to calculate a0, a1, a2 because all those contributes to 0. Okay, the only non-zero term is minus 1 to 1, p3x, p3x. Okay, so the p3x term will have coefficient 8 by 5, 8 by 5 p3x, p3x dx. 8 by 5 will come outside, and the integral minus 1 to 1 p3x, p3x dx is 2 divided by 2 into 3 plus 1. Answer is 16 by 35. Okay, I hope you understood why I neglected calculating a0, a1 and a2, because all those contributes to 0. Because a0 into p0x, p3x integral minus 1 to 1 is 0. p1x, p3x integral minus 1 to 1 is 0. p2x, p3x integral minus 1 to 1 is 0. The only non-zero term is p3x. And the final answer is 16 by 35. Okay, I hope it is clear. The remaining problems I will do in the next lecture. Thank you.